A rectangular mural is going to be painted on the side of a building, which is 8 meters longer than it is high. The total area for the mural is 240 meters squared. How tall is the building? Okay. So I might imagine this building, a nice, very box-shaped building. Now, I don't need the actual building itself. I'm interested in the side of the building where my mural is going to be painted. And they tell me I have 240 meters squared is the area of this rectangular side of the building. And that's a piece of information that we have in the scenario. Okay, what else do we know? Well, we are talking a bit about the dimensions. It's 8 meters longer than it is high, and we do want to know how high the building is, how tall it is. So we should probably talk about the dimensions of the building. Maybe you can say h for height or for how tall it is. And that's going to be one side of the rectangular mural size. And then there's also the length here, the length of the building. Now we could introduce another variable, but what do they tell us? They tell us it is 8 meters longer than it is high. So if we've already got a variable for the height, we don't really need a new variable for the length. We can just say it's h, whatever h is, plus 8 meters. Okay, so now we've got a nice little rectangle here. And we know its dimensions, at least in terms of this h, this unknown that we're trying to solve. So we've got the side lengths, and we know the area. And thanks to geometry, we can relate the two. The area of a rectangle is the length times the width. Okay, well, we can expand this out a little bit. We could subtract 240 from both sides. And now I've got a quadratic equation that I might want to solve. Okay, solve for h, my unknown, my height of the building, and that'll tell me how tall the building is, right? So can we think of two numbers that multiply to 240 and negative 240, of course, and add to 8? Okay, we might play around with the factors a little bit. Of course, you could always use the quadratic formula when in doubt. Let's see. Differ by 8. One of them is going to have to be negative. The other one's going to have to be positive. And the bigger one should be positive because we've got a surplus. We've got a plus 8 here. I think, yeah, negative 12 and 20. So I was just doing some factoring in my head. Of course, again, if you have trouble with that sort of thing, you can just jump straight to the quadratic formula. That always gives you the solutions here. But if you can factor, that's always good. So the only way this product will be 0 is if either h minus 12 is 0, so h is 12, or the height is negative 20. How can a building be negative 20 meters tall? Well, it can't. So we recognize that that is a silly answer. That's an impossible answer. So that means that the height of the building is 12 meters. Okay, the building is 12 meters tall. And if you want to work it out, the length of the building is 20 meters long or 20 meters wide, you might say. Okay? But the building is 12 meters tall, or 12 meters high, whatever you want to say.